Yeah, I just wanted to introduce about fundamentals of data structures, which is just an overview related to data structures, not an in-depth content. So here we have a person called Kernighan and Pike. The outcome of what is that they want to say is please start working with the data structures, existing data structures. They are sufficient enough to go ahead with any sort of applications. So smarter work is what they recommend. And let us understand what do you mean by maintaining some data in organized way and the other data which is in a disorganized way. So whenever your data or any content is which disorganized in nature, finding out the required item becomes very difficult. So to go ahead and make sure the items which you are trying to search for are found at a specified location with a minimal amount of time, it is better to organize your data. So thing is like it looks good and also accessing of data becomes very easy. For that is the reason we just make sure the data is in an organized state than getting into what is called as in a disorganized mode. So the data structures, whatever we are just talking, if you combine that data structure with algorithm, we say that together forms what is called as a program. So what is this data structures that we have just learned is to make sure your data is in some organized form rather than being in a disorganized form. So here are few set of things that we have been told since our childhood. Our parents ensure that we keep things in an organized way so that we can easily retrieve data or retrieve our things very fastly when you wanted to move out quickly for a school or etc. Right? So next, coming to what exactly is data structures. So the first thing you wanted to say is we need to organize data. First step, that is the basic purpose of organizing data. As I told you, organization always fetches you information very fastly. Now once it is organized, then we have to pick up some storage media to place it, right? And then after storing it properly, the next thing that becomes easy for us is to fetch your information, that is retrieving of that data, right? And finally, when you are able to retrieve your data efficiently, when I say efficiently means very quickly, if you are able to retrieve your data, then processing that information becomes easy. But if more amount of time is spent on retrieving itself, processing will be delayed. So all this time, if at all you are using your laptop or anything, your system becomes idle. Now this is not what we want in a real-time scenarios. So these all together form what is called as data structure. Basically you organize data, store it so that the way you organize will help you in retrieving the data very efficiently, and then processing becomes easy. Processing means for any reason you want to fetch some outcome from the existing data. That's the meaning of what is called as processing. So finally, data structures are divided into two types, like primitive data structures and non-primitive data structures. Primitive are the ones, when I say primed, the meaning is if at all you are going to store some data, and say if I say store in a particular small box an element, and at the same time I give one more item to be stored in the small box, maybe I don't have enough space in that, so I have to remove the previous one and then restore the new one. That is the meaning of remove primitive data structures. So primitive data structures are basic structures that directly operate upon the machine instructions. So few of them that are listed are integers, characters and float values, right? And so let's see what so we are basically moving into data structures. So most often we will not be concentrating on primitive data structures. These are the fundamental things that will be handled across many languages. So the next one that we have here is non-primitive data structures. Non-preemptive means you exactly, if you want to store the next element, you have enough storage space at another location where you can store. You need not preempt the previous value. So when data is more complicated and more of information has to be restored, better move on to non-preemptive data structures, right? So basically non-preempt is you group similar data, and we say that there is a quite good relationship between all these data items. So for example, if I want to say all roll numbers of a class will form one non-preemptive data structures. They are related. Every roll number is in similar form structured. So these non-preemptive data structures are further divided into two types, like linear and non-linear data structures. The meaning of linear thing is they are, you can access the data in a sequential form, like they are ordered very in a, like if I'm able to say this is the first element, the next element will be definitely adjacent towards that. So that becomes very easy for us to pick what is the next element or what is the previous element, if at all the elements exist. So in this case, linear data structures are explained through concepts called arrays, strings, stacks, queues, and lists. Right? So we'll just get into what you mean by arrays. So array is a group of similar data types. So we learned what are the preemptive data types. What are the primitive data types, like int, float, char. So if you are only grouping all integers together, then it is one type of an array. If you are grouping all float types together, it is another type of an array. Similarly, if you just group all characters, it will form another type of array. And the question is how to differentiate each element is we take the array name and differentiate every other element in the array via an index. So array name together with the index will differentiate every element, and that's how you can access all the elements here, right? And usually why these data structures we are looking is we wanted to organize and then perform some sort of retrieval operations. Whenever I say operations, it can be any sort of operations, retrieval operations that you wanted to do on top of this. So if you are able to club what are the properties related to the data structures and what all operations you can carry out on these data structures together into a single concept under a single umbrella, if I say, then it is called as an abstract data type. So abstract data type, if you take for example, what is abstract data type? When you wanted to talk about the primitive data structures called as an integer, then the properties that an integer can have is it can be a positive value or a negative value unless you specify it as an unsigned integer. And what all operations you can do on these integers, like add, subtract, multiply, divide, find a remainder. These are few of the operations that you can carry out on them. So if you can club the properties and operations together, it is called as an abstract data type. So here I'm not saying like what do you mean by add? How is that two integer elements are going to be added? So this sort of information is all hidden. So when information gets hidden, then we say that the entire representation gets into what is called as an abstract data type. And that's how we frame what is an abstract data type related to arrays. We say that the array may have a fixed number of n number of elements, and when I say n, I'm not saying again are these n elements as an integers or are all of them floats. So we stick on to the definition of an array. It should be related. That means all can be either integers or all can be real floats or all can be characters. What sort of operations you just carry on top of this is insert, delete, search, sort, traverse, etc. Right? So these are things that we generally do when you have some elements in this. So it's as simple as if you have if you pick up a biscuit packet, the biscuits are always organized in array form, and they are related because all of them will be of similar shape and same type. What is that you can do on top of the, you may want to search for third biscuit or a fourth biscuit, and if at all they are organized in various sizes, then you maybe you wanted to put them according to the size sorting. You want to find out how many of them are there, then it is traversing, or you want to remove one of them, right? And maybe you want to place back. These are delete and insert operations together, right? So these all form the base idea about uh, abstract data type related to arrays.